Hi, welcome to the third part of the video series about the work and energy. Calculating the work done by a friction force was covered in the previous video. The force of gravity is the next important force in this topic. In order to learn how to calculate the work done by the force of gravity, we will solve a few examples in this video. A 60 kg box falls from the top of a 30 meters high building. Calculate the work done by the gravitational force. Although the question is simple enough, sketching the diagram can make it easy to solve the question. Work is equal to force multiplied by displacement multiplied by the cosine of angle between these two. For this question, we have to calculate work done by the force of gravity, which can be expressed as mass of the object times gravitational acceleration. Object is moving downwards, which is also the direction of the gravitational force. As both point in the same direction, the angle between them is equal to 0 degrees. Mass of the object is 60 kilograms. Gravitational acceleration is 9.8 meters per second square. Magnitude of the displacement of the object is 30 meters and theta is 0 degrees. Work done by the force of gravity is equal to 17,640 joules. In this example, we have calculated the work of gravitational force on an object falling downwards. Now, let's see how to calculate the work done by the gravitational force on an object moving upwards. A 2 kg water rocket is launched vertically from the ground and reaches a final height of 10 meters. What is the work done by gravity on the rocket during its ascent? Once more, we start the solution by drawing a diagram which brings all the required information together. Then we write down the formula of work. Force of gravity is equal to m times g, mass times gravitational acceleration. This time, the water rocket is moving upwards, but the force of gravity is acting downwards. As they point in opposite directions, the angle between the two is equal to 180 degrees. Mass of the water rocket is 2 kilograms and g is 9.8 meters per second square. The magnitude of the displacement is 10 meters. So, work done by force of gravity is equal to negative 196 joules. In these two equations, objects were moving parallel to the force of gravity, either upwards or downwards. Let's calculate the work done by force of gravity on an object moving on a horizontal direction. A 5 kg object is horizontally dragged across the surface by a 40 Newton force acting parallel to the surface. Calculate work done by the force of gravity on the object through a distance of 12 meters. We have already seen similar question in the previous video. We can sketch the same diagram again. The next steps are same as with the previous two questions. We write down the formula of work and then express the force as mass times gravitational acceleration. Now it's time to sketch displacement and force of gravity. Object is moving to the right. Force of gravity is acting downwards. The angle between these two is equal to 90 degrees. We substitute the mass as 5 kgs, gravitational acceleration as 9.8 meters per second square, displacement as 12 meters, and the angle as 90 degrees. As the cosine 90 is equal to 0, work done on the object by the force of gravity is equal to 0 as well. Force of gravity does not have any effect on the motion of the object, thus it is not doing any work. The outcome of this question is that if a force applied on an object is acting at a right angle to the displacement, work done by this force is equal to 0. We can recall that the normal force is always acting perpendicular to the surface. Therefore, if an object is sliding across the surface, the work done by the normal force will always be equal to 0. It is the case for the work of gravity on the satellites orbiting a planet as well. In the next question, we have to calculate the work done by the force of gravity on a satellite orbiting the Earth. To be able to understand the solution, let's sketch the Earth and orbit around it, which represents the trajectory of a satellite. Work can be calculated as the force times displacement times cosine theta. To determine theta, we have to draw the direction of displacement and force. If an object is moving on a circular path, to determine its direction of motion at any point, we draw a tangent to this point. If the satellite moves in an anti-clockwise direction, the displacement at this specific moment will be in the direction of velocity. Earth will pull the satellite towards itself, meaning the direction of force is pointing to the center of the circle. As we know from the maths, an angle between the tangent and the radius is equal to 90 degrees. Even if we consider different position of satellite, we will always get right angle between the velocity and the displacement. Therefore, work is equal to F times delta x times cosine 90. As cosine 90 is equal to 0, the work done by the force of gravity is equal to 0. It can be hard to understand, as it seems that it is the force of gravity which causes the satellite to orbit around it. And this is true. Force of gravity is the reason why the satellite moves on a circular path. But it is not causing the satellite to move. Force of gravity just changed the direction of motion. In the absence of gravity, the satellite was going to move on a straight path. In this video, we had learned how to calculate the work done by the force of gravity on an object moving parallel or perpendicular to it. In the next one, we will calculate works done by the force of gravity, but this time objects will slide on an inclined plane. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.